Hi everyone. So today we're going to keep talking about this idea of converting standard form into factored form. Except the only difference today is we're going to be talking about when A, B, and C have a common factor. All right. When converting from standard form to factored, A, B, and C may all have a common factor. In this case, first factor the coefficients. So coefficients are A, B, and C. Then factor using the diamond method. Okay, so if I was to look at this first problem, I know that A is 2, B is 10, and C is 12. So what I notice is that potentially all of those numbers have a common factor. So the way that I can figure that out is figure out what multiplies to 2, 10, and 12. So for 2, I've got 1 and 2. For 10, I've got 1 and 10, and 2 and 5. For 12, I've got a few. I've got 1, 12, 3, 4, and 2 and 6. Okay? So now 1 I'm not going to include because anything is divisible by 1. So now I want to check if all of these have a common factor. 2 only has 2. So let's check 10 also has 2 as a common factor, and 12 also has 2 as a common factor. So that means that I could divide everything here by 2. And what I'm going to do is I'm going to divide them all by 2. I'm going to put the 2 outside. So factoring is almost like reverse distributive property. Okay? So 2 divided by 2, that gives me 1x squared. Positive 10 divided by 2, that gives me a positive 5x. And positive 12 divided by 2, that gives me a positive 6. So now I can use the diamond method because I've got A is equal to 1, B equal to 5, and C equal to 6. Just as a hint, you can use the diamond method just originally with these big numbers. It's just going to be way more of a hassle. So A times C, that gives me 6. B is 5. So two numbers that multiply to 6 and add to 5 are 2 and 3. So that means that now I'm going to write the 2 outside and then 2 sets of parentheses, x plus 2 and x plus 3. So that's how I fully factored this first example. All right, let's look at this next example. This next example has A is equal to negative 3, B is equal to negative 15, and C is equal to negative 18. So whenever A is negative, it might be a good start to make sure that the number that you divide out is going to be negative. So let's look at these factors. 3 has 1 and 3. 15 has 1 and 15, and 3 and 5. 18 has 1 and 18, 2 and 9, 3 and 6. So again, not going to use 1. Let's see if 3 is in all of these. And 3 is in all of these, so what I'm going to go ahead and do is divide out a negative 3 out of all of these. So negative 3 divided by negative 3, that creates 1x squared. Negative 15x divided by negative 3, that makes a positive 5x. And negative 18 divided by negative 3 makes a positive 6. Oh, and if you notice, x squared plus 5x plus 6, x squared plus 5x plus 6. So the only difference here was that they had a different common factor. So now I know that this is going to be negative 3 multiplied by x plus 2 multiplied by x plus 3. Okay? So let's see how this looks like in terms of factoring and then finding x-intercepts, y-intercepts, and the rest. Okay, so this first example I'm going to label A, B, and C. A is 2, B is negative 4, and C is negative 16. I ask myself the question, what divides out of all of these numbers? You can lay out all of the factors. 2 2, that's 1 and 2. 4 is going to be 1 and 4, 2 and 2. And 16 will be 1 and 16, 2 and 8, and 4 and 4. Okay, so 1 doesn't count. I start with the one with the least amount of factors, check if 2 is available in all of them, and 2 works in all of them. So I'm going to do my first step here, which is just factoring out the common factor for all the coefficients. So I've got 2. I'm going to divide 2 for all of these. So 2 divided by 2x squared divided by 2 makes 1x squared. Negative 4x divided by 2 makes negative 2x. And negative 16 divided by 2 makes negative 8. So now I can use the diamond method. So I've got a as 1 times c, that's negative 8. And then b is negative 2. So two numbers that multiply to negative 8 but add to negative 2. That's going to be a negative 4 and a positive 2. So now I've got 2 and x minus 4 and x plus 2 as my factored form. So f of x is equal to 2 multiplied by x minus 4 multiplied by x plus 2. Super convenient. I can find the x-intercepts really quickly. So I've got x minus 4 equals 0. I would add 4 to both sides. I've got x equals 4. X plus 2 equals 0. I would subtract 2 from both sides and get x equals negative 2. So I've got 4 comma 0 and negative 2 comma 0. For my y-intercept, I can just look at c from the original standard form. So I know that's just going to be 0 comma negative 16. And now this would be a good time to start sketching my graph. So I know if I need to go all the way down to negative 16, I might want to make my x-axis kind of higher, make my y-axis go a little bit lower. So positive 4, 0, 1, 2, 3, 4. Negative 2, 0, 1, 2. Negative 16. So here you could change up your scale if you wanted to, but make sure you label it if you do. I'm just going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is my y-intercept. Make my y-axis go a little bit longer here. Okay. And now I want to find the midpoint for the axis of symmetry. So I've got 1, 2, 3, 4, 5, 6 spaces. So half of that is going to be 3 spaces right at x equals 1. And then I can substitute that axis of symmetry to find the vertex. I'm going to use this second equation here. So f of 1 equals 2 multiplied by 1 minus 4 multiplied by 1 plus 2. So that's 2. 1 minus 4 make negative 3. 1 plus 2 make positive 3. So that's negative 6. Multiplied by positive 3, so that's negative 18. So 1, negative 18 is my vertex. So that's to the right one space and down 18. If this is 16, 17, 18. So I've got these 4 points that start to make the shape of my parabola. Okay? Let's move forward. Here's the second example. Second example, a is equal to negative 3, b is equal to 6, c is equal to 9, because it's negative 3x squared plus 6x plus 9. Okay, so I want to think if all of these have a common factor. You can just think about this in your head, but again, if you want to lay this out, I would recommend that whenever a is negative, that you do factor out a negative number. Okay, so now you've got 3, 6, 9. 3 is 1 and 3. 6 could be 1 and 6 or 2 and 3. 9 could be 1 and 9 or 3 and 3. If you don't want to do that, you can just think about what's the largest number that divides out of all 3 of these, and that would be 3. So again, we want to divide out a negative 3 so that we can make our a positive. So negative 3x squared divided by negative 3 makes a positive 1x squared. Positive 6x divided by negative 3 makes a negative 2x. And a positive 9 divided by a negative 3 makes a negative 3. So now, using my diamond, I've got a times c, that's 1 times negative 3, is negative 3. Now again, I'm using this a, this b, and this c now. And this is negative 2. So two numbers that multiply to negative 3 but add to negative 2. That's going to be a negative 3 and a positive 1. So I've got negative 3, just bringing that down. And my two other factors now are going to be x minus 3 and x plus 1. Okay, so to find my x-intercepts, I've got x minus 3 equals 0, meaning x equals positive 3 as an x-intercept. And x plus 1 equals 0, meaning I subtract 1, so x equals negative 1 is an x-intercept. Okay. My y-intercept, I can just look at my original c, which in this case is positive 9. So 0, 9 is my y-intercept. Okay. Since I know I'm going to be going up higher on the y-axis, I might want to make my x-axis lower. Let's see where we end up. So 3, 0, and it's helpful sometimes to label too, so you don't get lost. Negative 1, 0. And 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my y-intercept. So now my axis of symmetry is going to be the halfway point. 1, 2, 3, 4. Halfway of 4 is 2. So again, my axis of symmetry is x equals 1. Alright? So I'm going to substitute that 1 into this equation. So it's g of 1 equals negative 3 multiplied by 1 minus 3 multiplied by 1 plus 1. So that's negative 3 multiplied by negative 2 multiplied by positive 2, which makes a positive 6 multiplied by 2, which is positive 12. So g of 1 equals 12, meaning that my vertex is 1, 12. So if this is 9, 10, 11, 12, and 1, 12 is right about here. So I've got these 4 points. This parabola has a maximum and it's facing downwards.